champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in this session we are going to discuss NEET 2016 physics paper and we have 45 questions here. So let's start the session. The first question is from the chapter Work, Energy and Power, and the question is, what is the minimum velocity with which a body of mass m must enter a vertical loop of radius r so that it can complete the loop? Options are under root 5gr, under root gr, under root 2gr and under root 3gr. So the correct option will be option number A, that is under root 5gr. Okay. So this is the minimum velocity with which if a body enters a loop, vertical loop from any point, it can complete the loop. Okay. So you can just remember this directly, under root 5gr. So option A is the correct answer. Question number 2 is related to vectors, and the question is, if the magnitude of sum of two vectors is equal to the magnitude of difference of two vectors, then the angle between these two vectors is option A 180 degree, option B 0 degree, option C 90 degree and option D 45 degree. Okay. So according to this question, the sum of two vectors, let's say vector A plus vector B, is equal to the difference of these two vectors, that is vector A minus vector B. Okay. Now we know that vector A plus vector B can be written as A square plus B square plus 2AB cos theta. Okay. This is the formula for the sum of two vectors. Similarly, the difference of two vectors will be A square plus B square minus 2AB cos theta. So A square can be cancelled out because it is on both the sides. Similarly, B square will also be cancelled out. So what is left? 2AB cos theta this side, and this side also, this minus 2AB cos theta can be brought to the left hand side as plus 2AB cos theta. And this side, what is left? 0. So 2AB cos theta plus 2AB cos theta, that is 4AB cos theta, equals to 0. Now we have to find out this theta. So if we bring 4AB this side, it will be 0 only, because 0 divided by 4AB will be 0. So we can write that cos theta is equal to 0. And when is this possible? When theta is 90 degree. Okay, so theta will be cos inverse 0, that is 90 degree. So the correct option will be option number C. Question number 3 is from the chapter Gravitation, and the question is, at what height from the surface of the earth the gravitational potential and the value of G are minus 5.4 into 10 to the power 7 joule per kg and 6 meter per second square respectively. Take the radius of the earth as 6400 kilometer. Okay. So the value of gravitational potential, that is capital V, is given as minus 5.4 into 10 to the power 7 joule per kg, and the value of acceleration due to gravity is given as 6 meter per second square. Radius is also mentioned as 6400 kilometer. Okay. So we know that the gravitational potential is given by the formula minus Gm upon r plus h, where G is the gravitational constant, m is mass of the earth, r is radius of the earth and h is height. Okay. And this value is mentioned in this question as minus 5.4 into 10 to the power 7 joule per kg, right? So let's take it as equation number 1. Similarly, the value of acceleration due to gravity is given by the formula Gm upon r plus h whole square, and this value is given as 6 meter per second square. So we'll take it as equation number 2. Now we'll divide these two equations. Okay. So on dividing the two equations, that is V, gravitational potential divided by acceleration due to gravity, will get, so formula for V is minus Gm upon r plus h, and dividing by G. So this r plus h whole square of the small g will go here and Gm will come here. Okay. So Gm will be cancelled and this 1 r plus h will cancel the square. Okay. And on the right hand side we'll write the value. So the value of gravitational potential was mentioned as minus 5.4 into 10 to the power 7 and that of small g was 6. Okay. So on solving this we get 0.9 here. So minus 0.9 into 10 to the power 7, right? So what is left on the left hand side? It is minus r plus h, rest are cancelled, and on the right hand side we have minus 0.9 into 10 to the power 7. So again minus minus can be cancelled. Now let's simplify it. The value of r, that is radius, plus height h is equal to 0.9 into 10 to the power 7. So can we write it as 9 into 10 to the power 6, right? Again we'll break this 10 to the power 6 into 10 to the power 3 into 10 to the power 3. Okay, so first let's put the values of r. What is the value of r? Radius, it is 6400 kilometer. 6400 kilometer plus height is unknown, and this side we have 9 into 10 to the power 6, so we can write it as 9 into 10 to the power 3 into 10 to the power 3. Now 9 into 10 to the power 3, these are in meters, so we can write it as 9 kilometer, okay, into 10 to the power 3. So we can write it as 9000 kilometer. Okay, so on the right hand side we have 9000 kilometer. Now we can easily find out the value of height h, so that will be 9000 kilometer minus 6400 kilometer. So on finding the difference we get 2600 kilometer. Therefore option number B will be the correct answer. Okay, 2600 kilometer is the height at which these values are possible. Question number 4 is from the chapter electromagnetic induction, and the question is, a long solenoid has 1000 turns. When a current of 4 ampere flows through it, the magnetic flux linked with each turn of the solenoid is 4 into 10 to the power minus 3 Weber. The self-inductance of the solenoid is, okay, so the value of N, that is number of turns, is given as 1000. Current I is given as 4 ampere. Then the magnetic flux, that is phi, is given as 4 into 10 to the power minus 3 Weber. And we have to find out the self-inductance, that is capital L. Okay, so we'll use the formula N phi equals to L into I. Okay, so N is given as 1000. So we can write it as 10 to the power 3. Okay, into phi. Phi is given as 4 into 10 to the power minus 3. And this side we have L into I is the current, so it is 4 ampere. Okay. Now 10 to the power 3 will cancel 10 to the power minus 3. Then this side we have 4 and this side we have 4L. So the value of L will be 4 by 4, that is 1. So it is 1 Henry. So the correct answer will be option number A. 1 Henry is the value of self-inductance. Question number 5 is from the chapter alternating current, and the question is, an inductor 20 millihenry, a capacitor 50 microfarad and a resistor 40 ohm are connected in series across a source of EMF V equals to 10 sin 340t. The power loss in AC circuit is, okay, so what is power loss? Power loss will be equal to I square R. I square R, where I is the RMS current. Okay, but current is not given in this question. So in place of IRMS, we can write VRMS upon Z. Okay, so we can use this equation to find out the power loss. VRMS upon Z square R. Okay, Z is the impedance here. Now what will be the value of VRMS? See, here EMF is given as 10 sin 340t, and we know that the standard form of EMF is V equals to V naught sin omega t. So if we compare these two equations, we can say that the value of V naught is 10. So what will be the value of VRMS? It is equal to V naught by root 2. That is 10 by root 2. So from here we can get the value of VRMS, and that is equal to 10 by root 2. Okay, but we don't know the value of impedance. So let's see. In this question, the value of inductance is given as 20 millihenry. Okay, inductor is 20 millihenry. So inductance is 20 millihenry, that is 20 into 10 to the power minus 3 Henry. Okay, so using this we can find out the inductive reactance, that is XL. It is equal to omega L. Okay, this is the formula for inductive reactance. So what is the value of omega? See, in this equation V equals to 10 sin 340t, we can compare the value of omega. It is equal to 340. Okay, so omega is equal to 340 here. So we'll put this value 340 into L is 20 into 10 to the power minus 3. 20 into 10 to the power minus 3. So on solving this, we'll get 6.8, and the unit of reactance will be ohm. Okay, so inductive reactance is equal to 6.8 ohm. So let's put it as number 1. Similarly, capacitance is given as 50 microfarad. So it can be written as 50 microfarad, that is 50 into 10 to the power minus 6 farad, right? And we can find out the capacitive reactance, that is Xc. It is equal to 1 by omega c. So let's put the values again. 1 by omega is 340 and c is 50 into 10 to the power minus 6 farad. Okay. So on solving this, we'll get 58.8 ohm. So this is the value of capacitive reactance. Let's put it as number 2. And resistance is given as 40 ohm in this question. So the value of R is 40 ohm. So this is number 3. Now using these 1, 2 and 3, we can find out the value of impedance, that is Z. Okay. So impedance, that is Z, is equal to, it is given by the formula, under root R square plus XC minus XL whole square. Okay. So we'll just put these values here. R, that is resistance, is 40 ohm. So 40 square plus XC, that is this number 2, 58.8 minus XL, that is number 1, 6.8, okay, whole square. Now let's solve this. When you solve this, you'll get under root 4304 ohm. Okay, so this is the value of impedance. Now we have to find out the value of power loss. Okay, so we had seen that the power loss is equal to Vrms upon Z square R. So let's put the values. Vrms was equal to 10 by root 2 upon Z is equal to 4304 under root 4304. So square of this, and resistance is given as 40 ohm. Okay. So when you solve this, you'll get the values 0.51 watt approximately. Okay. So let's see which should be the correct answer. 0.51. Yes, option number B will be the correct answer. Question number 6 is from the chapter Electrostatics, and the question is, two identical charged spheres suspended from a common point by two massless strings of length L are initially at a distance d apart because of their mutual repulsion. The charges begin to leak from both the spheres at a constant rate. As a result, the spheres approach each other with a velocity v. Then v varies as a function of the distance x between the spheres as. Okay. So we have two spheres, identically charged spheres, which are suspended from a common point by two massless strings of length L each. Okay. Now these two spheres have same charge, say charge Q. Now there is a mutual repulsion between these two spheres. Due to that, they are at a certain distance d apart from each other. Okay. Now after some time, the charges start to leak from these two spheres. Due to that, there is decrease in repulsion and they start moving towards each other with the velocity v. So we have to find the relation between the velocity v and the distance x between the spheres. Okay. So here v varies as a function of the distance x between the spheres. So we'll consider d as equal to x. Okay. We'll consider this x only because we have to find the relation between v and x. So if we draw a line here, then we can say that this is x by 2 and this is also x by 2. Okay, half. And this angle can be taken as theta. Okay, we are considering this angle as theta. Now let's draw the free body diagram of this sphere. Okay, so one force will be acting downward, that will be equal to mg, and that will be balanced by an upward force, that is t cos theta. Okay. On the left hand side, we have the repulsive force or the electrostatic force, and that will be balanced by an opposite force, that is T sin theta. So let's write the equation for these two. T cos theta will balance mg. So that will be equal to mg. This is equation number 1. And T sin theta will be balancing the electrostatic force. And what is the formula for electrostatic force? It is K Q1 Q2 by distance square. Okay. So Q are same. So K Q square by distance is x. So x square. Okay. This is the electrostatic force. So this is equation number 2. Now we'll use these two equations to find the relation between v and x. Okay. So on dividing equation 2 by equation 1, on the left hand side we have t sine theta divided by t cos theta, and on the right hand side k q square upon x square will be divided by mg. Okay. So on the left hand side we got t cancelled, and sine theta by cos theta is equal to tan theta. And this side we have k q square upon mg x square. Okay. So this is what we got by dividing these two equations. Okay. Now here, if you look at this figure carefully, we can see a bigger triangle, and on dividing the base into two parts, we have two smaller triangles. Okay, so let's draw one of the triangles, the left one. Okay, so this base is equal to x by 2. This hypotenuse is L. Okay, x by 2 is base, and L is nothing but the hypotenuse of this triangle. Okay, and this is theta, because we have considered this angle as theta. So this is alternate angle, so this will also be equal to theta. Okay. Now here what will be the value of sine theta? Sine theta is equal to base by hypotenuse. Base is equal to x by 2, and the hypotenuse is L. So sine theta is equal to x by 2L, right? Now why we are taking sine theta? Because this theta is very small. It is given in this question that D is very small as compared to L. Therefore this angle theta will also be very small. Okay. So for small theta, for very small theta, we can say that tan theta is approximately equal to sine theta. Okay, so in this equation, in place of tan theta, we can write sine theta, and that is equal to k q square by mg x square. Okay, now sine theta is equal to base by hypotenuse, that is x by 2l. Okay, x by 2l. Now let's cross multiply these in order to solve. Okay, so here we get 2kl q square, and this side we get mg x cube. Okay, so what will be the value of q square? Q square will be equal to mg x cube upon 2kl. Okay, now what will be the value of q? It will be the root of this. Okay, root of mg x cube upon 2kl. See, you have to pay attention, otherwise you can get it wrong. Okay, so q will be equal to under root mg 2kl, and we can write x separately, the power of x separately, as x to the power 3 by 2. Okay, because root x means x to the power half, and the cube is already there, so x to the power 3 by 2. Okay, now we'll differentiate dq by dt. dq by dt is equal to under root mg by 2kl, because this part is constant, into 3 by 2 x to the power half dx by dt. Okay, now these are constants. Okay, these are constants, so in this place we can write c only. Okay, so dq by dt is equal to c into what is left here. This side we have x to the power half into dx by dt. Okay, now let's simplify. X to the power half means what? Root x, and dx by dt means velocity v. Okay, dx by dt is nothing but the velocity, and this side we have dq by dt, and we have seen that the dq by dt was constant. Okay, so this is also constant. This side also we have a constant dq by dt. So v will be inversely proportional to root x. Okay, if we take v this side, it will be inversely proportional. We can write root x is inversely proportional to v, or we can write v is inversely proportional to the root x. Okay, so let's see which relation will be the correct one. In option number D, we have V proportional to x to the power minus half. That means V proportional to root x. Okay. So option D will be the correct answer. Now question number 7 is again from the chapter electrostatic potential and capacitance, and the question is, a capacitor of 2 microfarad is charged as shown in the diagram. When the switch S is turned to position 2, the percentage of its stored energy dissipated is. Okay, so we can see that initially the switch is turned to position 1, so only the 2 microfarad capacitor will be charged and there will be some potential across this capacitor. So C1 is equal to 2 microfarad and the potential across this, that is V1 is equal to V volt. Whereas the second capacitor is uncharged. So C2 is equal to 8 microfarad and potential across this is 0 volt. Okay, there is no potential across this. But after some time the switch is turned to position 2. So in that case there will be the second capacitor will also start getting charged. That means the charge will start flowing from higher potential to lower potential until there is a common potential. So what will be the equivalent capacitance? The sum of these two capacitances, okay, C1 plus C2, because these are in parallel combination. So equivalent capacitance will be equal to 2 plus 8, that is 10 microfarad, and there will be some common potential after some time. So common potential is equal to C1 V1 plus C2 V2 upon C1 plus C2. Okay, so let's find out. C1 is 2 microfarad, V1 is V volt, C2 is 8 microfarad, V2 is 0, and C1 plus C2, that is 2 plus 8, 10. So here we get V by 5 volt. So common potential is equal to V by 5 volt. So this is the data that we have to keep in mind. Okay, the values C1, C2, C equivalent, V1, V2 and common potential. Now we'll use this in solving the question. So here we have to find out the percentage of stored energy dissipated. That means percentage of energy loss. We have to find the percentage of energy loss. So in that case we need to find the initial energy and final energy both, and then find the difference of initial and final energy. Okay, so what is initial energy? Initial energy stored, that is U1, is equal to half C1 V1 square, because only the first capacitor is charged here. So half C1 is equal to 2 microfarad and V1 is equal to V volt. Okay, so this is equal to, okay, V square. So half C1 and V square. So we get V square microjoule. So this is the initial energy stored. Now what is the final energy? So in the second case, both the capacitors are charged, right? So U2 will be equal to half into C equivalent into square of common potential, because both the capacitors will be used in this case. So half, and C equivalent is equal to 10 microfarad and common potential is equal to V by 5. So square of V by 5. So what do we get here? 2 into 5 is 10. So this is equal to V square by 5 microjoule. Okay, this is the final energy. So energy loss is equal to initial energy minus final energy. Okay, that is V square minus V square by 5 microjoule, that is 4 by 5. Okay, 4 by 5 V square. This is the energy loss, but we have to find out the percentage of energy loss. Okay, so percentage will be equal to energy loss upon initial energy into 100. Okay, so let's see. Energy loss is 4 by 5 V square. Initial energy was V square only, right, into 100. So that is equal to 4 by 5 into 100, that is 80%. So this is the percentage of energy dissipated or percentage of energy loss. So option A will be the correct answer. Okay, you can also use direct formula to find the energy loss. Okay, there is a formula for energy loss, and that is equal to, let's write it down here, C1 C2 upon 2 C1 plus C2, then V1 minus V2 whole square. You can also put values in this equation to find the energy loss, and then you can find the percentage of energy loss. It will be equal to 80% only. Okay, so option A is the correct answer. Now question number 8 is related to vector as well as work, energy and power, and the question is a particle moves so that its position vector is given by vector r equals to cos omega t x cap plus sin omega t y cap, where omega is a constant. Which of the following is true? Okay, so we have to find the relation between the position vector, velocity vector and the acceleration vector. Okay, we'll come to the options later on. First let's see what is given here. Position vector is given, so that is equal to cos omega t x cap plus sine omega t y cap. Okay, so what will be the velocity vector? It will be the differentiation of the position vector, that is dr by dt, right? So on differentiating the position vector, we get minus omega sine omega t x cap plus omega cos omega t y cap. Okay, this is the velocity vector. So let's find out the dot product of position vector and velocity vector. So this will show the relation between these two. So here we have cos omega t x cap, and this side we have minus omega sine omega t x cap. So the product will be minus omega sine omega t cos omega t. Similarly, the product of second term will be plus omega sine omega t cos omega t. So the same term is first in minus and then in plus, so it will be cancelled. So the overall dot product will be 0, right? And when the dot product is 0, it means cos theta is 0. So this shows that theta is equal to 90 degree. That means the angle between the position vector and velocity vector is 90 degree. So we can say that position vector and velocity are perpendicular to each other. Okay. So the first conclusion is that velocity is perpendicular to the position vector. Okay, this is the conclusion. Now we'll find the relation with acceleration. So how to find the acceleration? It will be the differentiation of velocity vector. So dv by dt. Let's differentiate the velocity vector. So on differentiating, we'll get minus omega square cos omega t x cap minus omega square sine omega t y cap. This is the differentiation of velocity, this one, right? So if we take minus omega square outside the bracket, so inside the bracket what will be left? Cos omega t x cap plus sine omega t x cap y cap. Okay, so this thing cos omega t x cap plus sine omega t y cap under the bracket is same as the position vector, right? So we can write that acceleration is equal to minus omega square into r cap. Okay, so what does this mean? This minus sign shows that acceleration and position are opposite to each other. Okay, acceleration is opposite to the position vector, and we know that the position vector is always directed from the origin towards the outside. Okay, so position vector is directed outside, that means acceleration will be directed towards the origin, opposite. Okay, so the second conclusion is that acceleration is directed towards the origin, because position is always away from the origin. Okay, so let's come to the options now. The first option says velocity is perpendicular to vector r. Yes, we have seen it is perpendicular to vector r. And acceleration is directed away from the origin. No, this is not true, because position is directed away from the origin, and since here acceleration is opposite, so it is directed towards the origin, not away from the origin. Okay, so this is not correct. Second option is velocity and acceleration both are perpendicular. No, we have seen that acceleration is not perpendicular, it is opposite. Okay, so this is also not true. Third option is velocity and acceleration both are parallel. This is also incorrect, because velocity is perpendicular, okay, not parallel. Then the last one is velocity is perpendicular to vector r. Yes, and acceleration is directed towards the origin. Yes, this is also true, because position is directed away from the origin, so acceleration is directed towards the origin, opposite. So option D will be the correct answer. Question number 9 is from the chapter Systems of Particles and Rotational Motion, and the question is, from a disk of radius r and mass m, A circular hole of diameter r whose rim passes through the center is cut. What is the moment of inertia of the remaining part of the disk about a perpendicular axis passing through the center? Okay, so we have a circular disk here whose radius is capital R and mass is capital M. Okay, then a hole is made in this disk such that the diameter of the hole is equal to capital R and its rim passes through the center of the disk. Okay, here. So we have to find the moment of inertia of the remaining part about a perpendicular axis passing through the center of the disk. That means about this axis. Okay. So if we draw the removed part here, where will this axis lie? At this position. At this position. Okay. Can you compare? So we have to use the same axis. First we'll find the moment of inertia of the main disk about this axis, then moment of inertia of the removed part about this same axis, and then we'll find the difference to get the moment of inertia of the remaining part, that is this shaded portion. Okay. So what is the moment of inertia of the main disk about a perpendicular axis passing through the center? That is given by the formula half mr square. Okay. But in the case of removed part, we have to find the moment of inertia about one of the tangents that is perpendicular to the plane of the disk. Okay, so that is given by 3 by 2 mr square. Here I am writing small m and small r because I am assuming that the mass of this smaller part is small m, removed part is small m, and the radius is small r. Okay, now what is the value of small r and small m in terms of capital R and capital M? Okay, because ultimately we have to find the answer in terms of capital M and capital R, right? So we know that the diameter of the removed part is equal to capital R, right? It was given in the question. So what will be the radius? It will be capital R by 2, okay, half of the diameter. And what is the mass of the removed part? That we have to find using the surface mass density. We know that surface mass density will remain constant, okay? Mass will change, volume will change, area will change, but surface mass density will remain same of both the parts, removed part as well as the initial part. So surface mass density means mass per unit area. So that will remain constant in both. And it shows that mass will be proportional to area. Okay. So here we know that radius of the smaller disk, that means the removed part, is half the radius of the bigger disk. Let's write it down here. Radius of removed part is equal to half the radius of main disk. Okay. So what will happen to area? Therefore, area of the removed part will be equal to 1/4 area of the main disk. Why? Because area is equal to, in area we use r square, square of radius, right? So since radius is half, area will be 1/4. Okay. So here we have seen that mass is proportional to area. So definitely mass will also be, mass of the removed part will also be equal to 1/4 mass of the main disk, because mass is directly proportional to area. Okay, so from here we can say that small m is equal to capital M by 4. So this you have to remember. Now let's proceed. What is the moment of inertia of? Moment of inertia of main disk is equal to half mr square. Moment of inertia of the removed part is, removed part was equal to 3 by 2 small m r square, right? 3 by 2 small m r square. Now we'll put the values. 3 by 2 small m is equal to capital M by 4 and small r is equal to capital R by 2. So square of this, okay? On solving here, we get 3 by 2 into m by 4, 3 by 2 into m by 4 into r square by 4. So that will be equal to 3 by 32. 3 by 32 mr square. Okay. So this is the moment of inertia of the removed part, and this is the moment of inertia of the main disk about the same axis. Okay, we are using the same axis. So moment of inertia of remaining part will be equal to half mr square minus 3 by 32 mr square, right? So on finding the difference, we get 13 by 32 mr square. Okay, so this is the moment of inertia of the remaining part of the disk about an axis which is perpendicular and passing through the center of this disk. Okay, so the same axis has been used. So 13 by 32 mr square, that means option C will be the correct answer. Question number 10 is from the chapter Gravitation, and the question is the ratio of escape velocity at Earth to the escape velocity at a planet whose radius and mean density are twice as that of the Earth is. Okay, so what is the formula for escape velocity? It is given as under root 2gm upon r. Here g is the gravitational constant, m is mass of the planet, and r is radius of the planet. Okay, but in this question radius and mean density are mentioned. So can we write mass in terms of density? Yes, we know that mass is equal to volume into density, right? And volume is equal to 4 by 3 pi r cube. This is the formula for volume, and density can be written as rho. Okay, so let's put this in this formula. We'll get under root 2g by r, and in place of m we are writing 4 by 3 pi r cube into rho. Now on solving this, we'll get 2 into 4 8 by 3 g pi r square, because this r will be cancelled and here r square will be left, and rho. Okay, so this is the formula for escape velocity in terms of mean density. Okay, and here 8 by 3 g and pi, these are constants, so we can write that the escape velocity is directly proportional to under root r square rho. Now we have to find out the ratio of the escape velocities of Earth, see escape velocity of the Earth to the escape velocity of the planet. So it will be equal to under root r square rho. R is the radius of the Earth and rho is the density of the Earth, divided by under root 2r square, because the radius of this planet is double the radius of the Earth. Okay, also the mean density is double the mean density of the Earth, so 2 rho. Okay, so here we get under root r square rho divided by, here we get 4r square into 2 rho, right? So r square cancelled, rho is cancelled, so here we get under root 1 by 8, and it can be written as 1 by 2 root 2, because root of 8 is 2 root 2. So the ratio will be 1 is to 2 root 2. That means option C will be the correct answer. Now question number 11 is from the chapter Current Electricity, and the question is a potentiometer wire is 100 centimeter long and a constant potential difference is maintained across it. Two cells are connected in series, first to support one another and then in opposite direction. The balance points are obtained at 50 centimeter and 10 centimeter from the positive end of the wire in the two cases. The ratio of EMFs is, okay. So two cases are mentioned here. In case 1, the cells are connected in series. Okay, so the resultant EMF here will be equal to E1 plus E2. Okay, and in second case, the cells are opposite to each other. So in this case, the resultant EMF will be E1 minus E2. Okay, and we know that EMF is equal to K into L, where K is the potential gradient, and L is the balancing length or balancing point. Okay, so in the first case, E1 plus E2 will be equal to K into L1, and here it is given that L1 is 50 centimeter. Okay, the balancing point is 50 centimeter in first case. And in second case it is 10 centimeter. So E1 minus E2 will be equal to K into 10 centimeter. Okay, this is the second one. So let's write the ratio of these two. So E1 plus E2 by E1 minus E2 will be equal to K into 50 by K into 10. Okay, so K will be cancelled. So we get 5. The ratio is 5. Okay, now let's take E1 minus E2 this side. So we get E1 plus E2 equals to 5E1 minus 5E2. Now let's write E2 on one side and E1 on the other side. Okay, so E2 plus 5E2 equals to 5E1 minus E1. And by arranging these, we can find the ratio of E1 and E2. So this side we get E2 plus 5E2, that is 6E2. And this side 5E1 minus E1, that is 4E1. And we have to find out the ratio of EMF, that means E1 by E2, right? So it's very simple now. E1 by E2 will be equal to 6 by 4. So on solving this, we get 3 by 2. So this ratio will be equal to 3:2. So let's see. In the first option only, we have 3:2. So this is the ratio of EMF. So option A will be the correct answer. Question number 12 is from the chapter Wave Optics, and the question is, a siren emitting a sound of frequency 800 Hz moves away from an observer towards a cliff at a speed of 15 meters per second. Then the frequency of sound that the observer hears in the echo reflected from the cliff is, okay. The velocity of the sound in air is to be taken as 330 meters per second. So the velocity of the sound is 330 meters per second. Velocity of the observer, that is V0, is 0 because it is at rest, and velocity of the source is 15 meter per second because siren is the source here and it is moving at a speed of 15 meter per second. Okay, now we have to find out the frequency f dash. So that is equal to f naught V minus V naught by V minus Vs. Okay, f naught is 800 Hertz. V is the speed of sound, that is 330 meter per second, minus V naught is the speed of the observer, that is 0. Then again 330 minus velocity of the source, that is 15 meter per second. Okay, so that is equal to 800 here, and this side we have 330 divided by 330 minus 15, that is 315. Okay, so on solving this, we'll get 838 and the unit of frequency is Hertz. So 838 Hertz, that means option D will be the correct answer. Now question number 13 is from the chapter Semiconductor Electronics, and the question is, to get output 1 for the following circuit, the correct choice for the input is, okay. So two gates are represented here. The first one is OR gate and this is AND gate, okay. The output coming from AND gate is Y and this is the final output. So we have to find the values of A, B and C so that the value of Y should be 1. Okay, so we can see that 1 is coming out of AND gate, and when do we get 1 as output from AND gate? When both the inputs are 1. Okay, so this should also be 1 and this should also be 1. Okay, that means the output from this OR gate should be 1 as well as this C should be 1. So in the given options, we can see that there is only one option where C is equal to 1. In other, C is 0. So these cannot be the correct answer. So option A will be the correct answer. Also, in OR gate, the output will be 1 if only one of the inputs is 1. Okay, and the other is 0. So we can see that A is 1 and B is 0. So yes, this is possible. So option A will be the correct answer. Question number 14 is from the chapter Wave Optics, and the question is, in a diffraction pattern due to a single slit of width A, the first minimum is observed at an angle 30 degree when light of wavelength 5000 angstrom is incident on the slit. The first secondary maximum is observed at an angle of, okay. So for first minima, n is equal to 1 and the angle theta is given as 30 degree. So we'll use the Bragg's equation here, okay. So from Bragg's equation equation, we can say that A sine theta is equal to n lambda, right? Now theta is 30 degree and n is equal to 1, right? So we can write that A sine 30 degree is equal to lambda because n is equal to 1 and sine 30 degree is equal to half. So A by 2 is equal to lambda. So from here we get the value of A, that is twice the wavelength, that is A equal to 2 lambda. Okay. So let's put it as equation number 1. Now for secondary maxima. For secondary maxima, we already know the value of A, that is equal to 2 lambda, right? Now for secondary maxima, using Bragg's equation, we can write that A sine theta dash, let's say that the angle in this case is theta dash, so that is equal to 3 by 2 lambda, right? For secondary maxima. Now the value of A is 2 lambda. So 2 lambda into sine theta dash is equal to 3 by 2 lambda. Lambda is on both sides, so cancelled. So sine theta dash is equal to 3 by 4. Okay. So what will be the value of theta dash? That will be equal to sine inverse 3 by 4. So the correct option will be option number A, sine inverse 3 by 4. This is the angle that is observed. Question number 15 is from photoelectric effect, and the question is, when a metallic surface is illuminated with radiation of wavelength lambda, the stopping potential is V. If the same surface is illuminated with radiation of wavelength 2 lambda, the stopping potential is V by 4. The threshold wavelength for the metallic surface is, okay. So we know the equation kinetic energy equals to EV, and that is equal to hc by lambda minus phi, okay. V is the stopping potential, lambda is the wavelength, okay. And what is the value of phi? Phi is equal to hc by lambda naught, where lambda naught is the threshold wavelength. Threshold wavelength about which the question has been asked, okay. So we have to find the value of lambda naught in terms of lambda, okay. So first we'll use phi only. So let's suppose this equation EV equals to hc by lambda minus phi is equation number 1. Okay. So in second case, what happens? Same surface is illuminated with the radiation of wavelength 2 lambda, and in that case stopping potential becomes V by 4. So if we put 2 lambda in this equation, V will become V by 4. Let's write it down. EV by 4 equals to hc by 2 lambda, okay, minus phi. Now let's assume this is equation number 2. Now, if we multiply equation 2 by 4 or we divide equation 1 by 4, then both the equations can become equal. Okay. So, let's multiply equation 2 by 4. Okay. So, by multiplying equation 2 by 4, so EV by 4 into 4 equals to hc by 2 lambda into 4 minus 4 phi. Okay. So this side 4 will be cancelled. This side 2 into 2 is 4. So it can be written as EV equals to 2 hc by lambda minus 4 phi. Okay. So now in equation number 1 and in this equation, the left hand side is same. That means EV. Okay. So right hand side will also be same. So hc by lambda minus phi of equation 1 will be equal to 2 hc by lambda minus 4 phi of this equation. Okay. So let's equate these two. Hc by lambda minus phi will be equal to 2 hc by lambda minus 4 phi. Okay. Let's put phi on one side. So minus phi plus 4 phi, and this side we have 2 hc by lambda minus hc by lambda. Okay. So 3 phi equals to hc by lambda, right? Now we know that phi is equal to hc by lambda naught. So 3 hc by lambda naught equals to hc by lambda. So from here we can say that the value of lambda naught is equal to 3 lambda. Okay. So which option will be the correct one? 3 lambda. Option A will be the correct answer. Okay. Threshold wavelength is equal to 3 lambda. Question number 16 is from the chapter Atoms, and the question is, when an alpha particle of mass m moving with velocity v bombards on a heavy nucleus of charge Ze, its distance of closest approach from the nucleus depends on m as. Okay, so we have to find the relation between the distance of closest approach, that is r, and mass of alpha particle, that is m. Okay, now what happens at closest approach? At closest approach, kinetic energy completely gets converted into potential energy. Okay, so kinetic energy is converted to potential energy. Kinetic energy, that means half mv square, and that will be equal to the potential energy. That means, what is potential energy? K q1 q2 upon r. Okay, so here K is the constant, q1 is charge on alpha particle, that is equal to 2e, q2 is charge on the nucleus, that is given as Ze, and r is the distance of closest approach in this case. Okay, so from here we can say that mass is inversely proportional to r. Okay, that is the distance of closest approach. Okay, mass is inversely proportional to r, or we can say that r is inversely proportional to mass. So it will be inversely proportional to mass. That means option B will be the correct answer. Question number 17 is from the chapter Ray Optics and Optical Instruments, and the question is, match the corresponding entries of column 1 with column 2 where M is magnification produced by the mirror. Okay, so we have to match the magnification with correct type of mirror. In the first one, M, that is magnification, is given as -2. Now minus sign means the image is inverted. Okay, it is inverted. If it is positive, it means it is erect, but minus means inverted, and 2 is more than 1, right? If it is more than 1, that means it will be magnified image, right? Magnified. Now this shows that the image will be real, because inverted images are always real. Okay, and it is possible only in case of concave mirror. So real image and concave mirror. So it will be matched with B and C both. Okay. In option number B, A is matched with B and C. Right. Now we come to the second one. Here magnification is given as -half. Minus, again it means inverted image. Inverted. And half is less than 1. Right. Less than 1, it means it will not be magnified. Instead it will be diminished. Okay, more than 1 means magnified, less than 1 means diminished. So here the image will be inverted and diminished, and since it is inverted, it will again be real image. Okay, it will be a real image. And which type of mirror? In which type of mirror it is possible? Again, concave mirror. Okay, so it will also be matched with B and C both. So here you can see in option number B, B is matched with B and C. Okay, now we come to the third one. Here magnification is given as +2. So this time plus means what? It will be erect, not inverted. Okay, so it is erect, and 2 is more than 1, then again magnified. So erect and magnified. We have seen that inverted means real and erect means virtual. Okay, erect means the image will be virtual. So in which type of mirror it is possible? It is again possible in concave mirror only. Okay, so virtual image and concave mirror. So it will be matched with number B, that is concave mirror, and number D, that is virtual image. Okay, so you can see here C is matched with B and D. And the last one, we have magnification +half. So this time again half means it will be diminished, but plus means it will be erect. Okay, so erect and diminished. And since it is erect, it means it will be virtual. Okay. Inverted means real and erect means virtual. And type of mirror in which it is possible, it convex mirror. So the correct matches will be virtual and convex. That means A and D. Okay, so here you can see D is matched with A and D. So option B will be the correct answer. Question number 18 is from the chapter Work, Energy and Power. And the question is, a particle of mass 10 gram moves along a circle of radius 6.4 centimeter with a constant tangential acceleration. What is the magnitude of this acceleration if the kinetic energy of the particle becomes equal to 8 into 10 to the power minus 4 joule by the end of second revolution after beginning of the motion? Okay. So mass is given as 10 grams. That means 10 into 10 to the power minus 3 kg. Okay, or we can write 10 to the power minus 2 kg. Now this particle is moving along a circle of radius 6.4 centimeter. So radius is 6.4 centimeter or 6.4 into 10 to the power minus 2 meter. Okay, with a constant tangential acceleration, and we have to find the magnitude of that acceleration if kinetic energy becomes 8 into 10 to the power minus 4 joule. So kinetic energy is also given here, 8 into 10 to the power minus 4 joule by the end of second revolution. So the number of revolutions n is given as 2. What will be the total distance traveled? See, we know that for one revolution the total distance travel will be 2 pi r. Okay, 2 pi r for one revolution. So for two revolutions it will be 4 pi r. 4 pi r. We are using capital R for radius, right? Now the total work done will be equal to change in kinetic energy. Okay, work energy theorem. What are the total works done? First, work is done due to centripetal force in circular motion, and then work is also done by the tangential force. Okay, tangential force, and that is equal to change in kinetic energy. Work done due to centripetal force is always 0, right? So only tangent work done will by the tangential force will be applicable here. Okay, so what is the work done due to tangential force? Force into the total distance traveled. Okay, and force is equal to mass into acceleration, and into the total distance traveled, that will be equal to change in kinetic energy. Okay, so we have to find out the magnitude of acceleration. That will be equal to kinetic energy divided by mass into distance traveled. Okay, so let's put the values. Kinetic energy is given as 8 into 10 to the power minus 4 joule divided by mass, that is given as 10 to the power minus 2 kg, into distance traveled is 4 pi r, that is 4 into pi is 3.14, and r, that is radius, is equal to 6.4 into 10 to the power minus 2 meter. Okay, so on solving this we'll get approximately 0.1, and the unit will be meter per second square. Okay, so the correct answer will be option number B, 0.1 meter per second square. Question number 19 is from the chapter Alternating Current, and the question is, a small signal voltage Vt equals to V0 sine omega t is applied across an ideal capacitor C. Okay, so what happens in case of ideal capacitor? The current leads voltage by 90 degree, right? In case of ideal capacitor, current leads voltage by 90 degree, that is pi by 2. Okay, so let's see the options. In the first option it is given that current leads voltage by 180 degree. It is not true, it leads by 90 degree. Okay, then the second option is current lags voltage by 90 degree. No, it does not lag, it leads by 90 degree. Okay, so this is also not true. Third one is, over a full cycle the capacitor C does not consume any energy from the voltage source. Yes, it will not consume any energy from the voltage source because the capacitor itself gets charged and uncharged. Okay, and the last one is, current is in phase with voltage. This is also incorrect. It is not in phase, it leads the voltage. Okay, so you can also do by elimination technique. A, B and D are absolutely incorrect, so only option C can be the correct answer. Question number 20 is from the chapter Systems of Particles and Rotational Motion, and the question is a disk and sphere of same radius but different masses roll off on two inclined planes of the same altitude and length. Which one of the two objects gets to the bottom of the plane first? Okay, so suppose the inclined planes are of length L. Okay, then distance traveled by the body will be equal to ut plus half at square. U will be 0, so S will be equal to half at square, right? And S is the distance traveled by the body, that is equal to length of the inclined plane. So L is equal to half at square. Now we know that the acceleration of a rolling body on an inclined plane is given by the formula g sine theta upon 1 plus k square by r square. Okay. So let's put the values. L equals to half g sine theta upon 1 plus k square by r square. So this is the acceleration, and then t square. So what will be the value of t? T will be equal to under root 2l by g sine theta into 1 plus k square by r square. So we can say that time is directly proportional to under root 1 plus k square by r square. Okay. So this we have to keep in mind. Now for a disk about its central axis, moment of inertia is mr square by 2. Okay, so for the disk, k square by r square is equal to half, and for a sphere it is the k square by r square is equal to 2 by 5. Okay, so which one is less? Sphere, k square by r square is less. Okay, so for sphere, time will also be less. Okay, it will take less time to reach the bottom. Less time. So sphere will reach the bottom first. So option C will be the correct answer. Question number 21 is from thermal properties of matter, and the question is coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Lengths of brass and steel rods are L1 and L2 respectively. If L2 minus L1 is maintained same at all temperatures, which one of the following relations hold good? Okay, so we know that the change in length in case of linear expansion is given by the formula L alpha delta T. Okay, so delta L is given by the formula L alpha delta T, where L is the initial length, alpha is coefficient of linear expansion, and delta T is the temperature change. Okay, change in temperature. So what will be new length? New length, that is L dash, is equal to initial length L plus delta L. Okay, so that is equal to L plus L alpha delta T. Now if we take L common or outside the bracket, it will be L 1 plus alpha delta T. So this is the formula for new length after the expansion. Okay, now here we have two types of materials, brass and steel. Okay, so if we talk about the first one, that is for brass rod, its initial length is given as L1. Okay, and coefficient of linear expansion is alpha 1. So the change in length, that is delta L1, will be equal to L1 alpha 1 delta T, right? And the new length, that is L1 dash, will be equal to L1 1 plus alpha 1 delta T. Okay, this is the formula for increased length. Similarly, for the second one, that is steel rod. Here the new length, that is L2 dash, will be equal to L2 1 plus alpha 2 delta T. Okay, so let's take it as equation number 1 and this one as equation number 2. Now let's subtract equation 1 from equation 2. Okay, so on subtracting equation 1 from equation 2, left hand side we have L2 dash minus L1 dash, and this side we have L2 1 plus alpha 2 delta t minus L1 1 plus alpha 1 delta t, right? Now let's solve it further. Here if we open the bracket, it will be L2 plus L2 alpha 2 delta t minus L1 minus L1 alpha 1 delta t. Okay. Now if we take L2 and L1 together, so L2 minus L1, and then this side we have plus L2 alpha 2 delta t minus L1 alpha 1 delta t. Okay. And this side we have L2 dash minus L1 dash. Okay. Now according to the question, L2 minus L1 is maintained same. So this L2 dash minus L1 dash will be equal to L2 minus L1. Okay, because this is same. So this one becomes equal to 0, right? So L2 alpha 2 minus L1 alpha 1, I am taking delta t outside the bracket, is equal to 0. Okay, when delta t comes this side, it becomes 0 only. So we can say that L2 alpha 2 minus L1 alpha 1 is equal to 0. So L2 alpha 2 is equal to L1 alpha 1. Okay, or L1 alpha 1 equals to L2 alpha 2. So this is the relation. Okay, L1 alpha 1 equals to L2 alpha 2. So now let's see. First one is alpha 1 L1 equals to alpha 2 L2. Yes, this is the correct relation, right? So option A will be the correct answer. Now question number 22 is from the chapter Ray Optics and Optical Instruments, and the question is, an astronomical telescope has an objective and eyepiece of focal length 40 cm and 4 cm respectively. To view an object 200 cm away from the objective, the lenses must be separated by a distance. Okay, so we have two lenses. First one is the objective lens and the other is eyepiece. Okay, so suppose this is objective lens and this is eyepiece. Now we have to view an object that is kept at 200 cm away from the objective. Okay, so it is kept somewhere here. Okay, this is 200 cm. This is object distance, that is u. Okay, so object distance u is given as minus 200 cm. We'll write it in negative, right? And the focal length of the objective FO is given as 40 centimeter. Okay, 40 centimeter. So from here we can find out the image distance from the objective, right, by using the lens formula, that is 1 by V equals to 1 by U plus 1 by F. Okay, F is the focal length. So 1 by V is equal to 1 by minus 200 or minus 1 by 200 plus 1 by 40. Okay, so let's solve it. It will be 200 this side. Here we have minus 1. It will be 1 plus 5. Okay, so it will be 4 upon 200. That means 1 by 50. So the value of V, that is image distance, will be equal to 50 centimeter. Okay, this is the image distance from the objective lens. Okay, so the image will be formed somewhere here. This is the image. Okay, image. So this is at 50 centimeter from the objective. Now we know that the objective, that the image should be formed. Image must be formed at the focal length of the eyepiece. Okay, focal length of the eyepiece. So this image should be 4 centimeter away from the eyepiece, because focal length of the eyepiece is 4 centimeter. Okay, that is 4 centimeter from the eyepiece. Now here we have seen that this distance from the objective lens to the image is 50 centimeter, and the distance between this image and the eyepiece is 4 centimeter. Okay, so the total distance will be what? 50 plus 4. Okay, so the total distance between the lenses will be equal to image distance from the objective plus the focal length of the eyepiece. Okay, so that is 50 centimeter plus 4 centimeter, that is equal to 54 centimeter. Okay, so this should be the distance of separation between the two lenses. Okay, 54 centimeter. So the first option only is the correct one, 54 centimeter. Option A is the correct answer. Next question is from the chapter Systems of Particles and Rotational Motion, and the question is: a uniform circular disc of radius 50 centimeter at rest is free to turn about an axis which is perpendicular to its plane and passes through its center. It is subjected to a torque which produces a constant angular acceleration of 2 radian per second square. Its net acceleration in meter per second square at the end of 2 seconds is approximately. Okay, so we have a uniform circular disc rotating about an axis that is passing through its center and is perpendicular to its plane. Okay, radius of this disc is given as 50 centimeter, so it can be written as 0.5 meter. Okay, then the angular acceleration, that is alpha, is given as 2 radian per second square. We have to find the net acceleration at the end of 2 seconds. So time is given as 2 seconds. Also it is given that this disk was initially at rest. Okay, so the initial angular velocity, that is omega naught, was equal to 0. So can we find the final angular velocity? We know that omega final will be equal to omega naught, that is initial omega, plus alpha t. Okay, this is same as the equation v equals to u plus at. So for angular it will be omega f equals to omega naught plus alpha t. Okay, so the final omega will be equal to initial omega, that is 0, plus alpha is equal to 2 radian per second square, and time is also 2 seconds. So this will be equal to 4 meter per second. This will be the angular velocity. Okay, final angular velocity. Now two types of accelerations will be there. Okay, first will be centripetal acceleration, that is AC. Okay, so centripetal acceleration will be equal to omega square r. Omega is equal to 4 meter per second square, so 4 square into r is 0.5 meter, so that will be equal to 16 into 0.5, that is 8 meter per second square. This is the centripetal acceleration. Second type of acceleration that will be applicable here is the tangential acceleration. Okay, so that will be equal to alpha into r. Alpha is equal to 2 radian per second square, so 2 into radius is 0.5, so that will be equal to 1 meter per second square. So we have got centripetal acceleration as well as tangential acceleration, and now we have to find the net acceleration, right? Net acceleration, and that is given by the formula under root AC square plus AT square, where AC is the centripetal acceleration and AT is the tangential acceleration. Okay, so let's put the values here. AC was equal to 8 meter per second square, so 8 square plus tangential was 1 meter per second square. Okay, so it is equal to under root 64 plus 1, that is under root 65, and that will be equal to 8 point something, so approximately equal to 8. Okay, 8 meter per second square. So the correct option will be option number B. Okay. Question number 24 is from the chapter Thermodynamics, and the question is: a refrigerator works between 4 degree and 30 degrees Celsius. It is required to remove 600 calories of heat every second in order to keep the temperature of the refrigerated space constant. The power required is, okay, 1 calorie can be taken as 4.2 joules. So we know that the coefficient of performance of refrigerator, that is beta, is equal to Q2 upon W, and that is equal to T2 upon T1 minus T2. Okay, so what is Q2 here? Q2 is the heat extracted or removed from the cold reservoir, that is refrigerator. So how much heat is removed? 600 calories according to this question. So Q2 is equal to 600 calories. In joule it will be 600 into 4.2 joules. So that is equal to 2520 joules. Okay, Now what is T2 and T1? So T1 is the higher temperature or temperature of the room. So that is given as 30 degrees Celsius, right? So 30 degrees Celsius means 273 plus 30 Kelvin. That will be equal to 303 Kelvin. And T2 is the temperature inside the refrigerator, that is given as 4 degrees Celsius. So 273 plus 4 Kelvin, that is 277 Kelvin. Okay. So now we got the values of Q2, T2, T1 and T2. So let's put the values. Q2 by W. Q2 is 2520 Joule. Okay. W is unknown, that is work done is unknown, that we'll calculate right now. T2 is 277 Kelvin. T1 is 303 and T2 is 277. Okay. So 303 minus 277. So let's solve. 2520 upon the work done will be equal to 277 upon 303 minus 277 will be equal to 26. Okay. So from here we can get the value of work done, that is equal to 2520 into 26 upon 277. So on solving this we'll get 236.5 Joule. Okay. This is the work done and we have to find out the power, that is work per unit time. So time is 1 second because this much heat is removed per second. Okay. So power is work per unit time. Work upon time. So that is 236.5 Joule by 1 second. So that will be 236 only. Okay. 236.5 Joule only. 5 watt. The unit will change into watt, right? So 236.5 watt. That means the last option, option number D, is the correct answer. Okay. Now question number 25 is again from the chapter thermodynamics, and the question is, a gas is compressed isothermally to half its initial volume. The same gas is compressed separately through an adiabatic process until its volume is again reduced to half. Then option A, which of the case, whether compression through isothermal or through adiabatic process, requires more work will depend upon the atomicity of the gas. Option B, compressing the gas isothermally will require more work to be done. Option C, compressing the gas through adiabatic process will require more work to be done. And the last option is, compressing the gas isothermally or adiabatically will require the same amount of work. Okay. So we know that work done can be estimated by area under the PV graph. Okay. We know that area under PV graph, that is pressure versus volume graph, gives the work done. Okay. So let's see, if we draw the pressure versus volume graph for these two cases, this side we have P and this side we have volume. Okay. So for adiabatic, the graph will be something like this, adiabatic compression, and for isothermal it will be below the adiabatic. So this is for isothermal, right? Now if we draw the graph here, then this is the shaded portion. This is the above one is for the adiabatic and the lower one is isothermal. Okay. So we know that isothermal graph has the area under PV graph as the unshaded portion. Okay. Unshaded part. That means the lower part. Okay. So this is less. Okay. This area is less as compared to that of adiabatic. Okay. Because when we see the adiabatic graph, it is the unshaded part plus the shaded part. Okay. The total area is shaded plus unshaded, that is more than that of isothermal. Okay. So we can say that the area under the PV graph is more for adiabatic compression. Okay. So the work done will also be more for adiabatic expression. Okay. So for adiabatic compression, more area means more work is required to be done. Okay. More work done. So which option should be the correct one? Option number C, compressing the gas through adiabatic process will require more work to be done. Okay, option C is the correct answer. Question number 26 is from the chapter Wave Optics, and the question is the intensity at the maximum in Young's double slit experiment is I naught. Distance between two slits is small d equals to 5 lambda, where lambda is the wavelength of light used in the experiment. What will be the intensity in front of one of the slits on the screen placed at a distance capital D equals to 10 times small d? Okay, so we have two slits here. Suppose this is slit 1, this is slit 2. So the distance between these two slits is equal to small d. Now if we have a screen placed at this point, then this distance is equal to capital D, right? Now in between the slits there will be central maxima. Let's say this is point O. So at this point O, the intensity will be maximum, that is I naught. Okay, but we have to find the intensity in front of one of the slits. So suppose we have to find the intensity in front of slit 1. So if this is point P, then we have to find the intensity at point P. Okay, and what is the distance between point O and P? That will be equal to y equals to small d by 2. Okay, so this distance is taken as y, and that will be equal to d by 2. Okay, now few things should be kept in mind. First, that intensity of light is taken as I max, that is I naught, into cos square phi by 2, where phi is the phase difference. Okay, second thing is relation between phase difference and path difference. So phase difference is equal to 2 pi by lambda into path difference. Okay, delta x is the path difference. And third, path difference is also equal to y into small d by capital D. Okay, so delta x is path difference, whereas phi is the phase difference. Okay, now let's start the question. So given, what is given in this question? It is given that small d is equal to 5 lambda and capital D is equal to 10 times small d, right? Now we'll start by finding the path difference. So what will be the path difference in this case? It will be equal to y into small d by capital D. So y is equal to d by 2. Okay, y is equal to d by 2 into small d upon capital D, and capital D is equal to 10 times small d, right? So one small d will be cancelled from here. Here we'll have d by 20. And what is the value of small d? It is 5 lambda. So 5 lambda by 20, that means lambda by 4. Okay, so lambda by 4 is the path difference. Now using this, we'll find the phase difference by using the second point. Okay, so phase difference, that is phi, will be equal to 2 pi by lambda into delta x. Okay, 2 pi by lambda into path difference. So let's put the values. 2 pi by lambda into path difference is lambda by 4. So lambda cancelled, 2 into 2 is 4. So what is left here? Pi by 2. Okay, so pi by 2 is the phase difference. Okay, this is the phase difference. Now by using the phase difference, we can find out the intensity. Okay, so first we found the path difference, then we found the phase difference, and now we can find the intensity. So intensity I is equal to maximum intensity I naught into cos square phi by 2. So let's put the values. I naught cos square phi by 2. Phi is equal to pi by 2, right? So pi by 2 divided by 2, that means pi by 4. Okay, and cos pi by 4 is equal to 1 by root 2. Okay, so I naught 1 by root 2 square. Okay, cos pi by 4 is equal to 1 by root 2. So cos square will be square of 1 by root 2. So here we can get I naught by 2. Okay, so the intensity will be equal to I naught by 2. That means half of maximum intensity. So option A will be the correct answer. Okay. Question number 27 is from the chapter Mechanical Properties of Fluids, and the question is two non-mixing liquids of densities rho and n rho, where n is greater than 1, are put in container. The height of each liquid is h. A solid cylinder of length capital L and density small d is put in this container. the cylinder floats with its axis vertical and length PL, where P is less than 1, in the denser liquid. The density D is equal to. Okay. So let's understand the question here and pay attention right from the beginning, because this is going to be a lengthy solution. Okay. So we have a container. Say this is your container. We have two different liquids with different densities. Okay. So suppose this is the point of separation of the two liquids. Okay. Now in the first line of the question, it is given that the densities of the liquids are rho and n rho. So which one is more? N rho is more because n is greater than 1. Okay. So the denser liquid will have this density n rho. Okay. So this is the density of the denser liquid. So we know that the denser liquid will be present on the bottom side of the container. So this side liquid will have the density n rho, whereas the lighter liquid that is on the top side will have the density rho. Okay. Height of each liquid is small h. Now a cylinder, solid cylinder is put inside this container like this. Now as you can see that some part of the cylinder is in the denser liquid and some part of the cylinder is in the lighter liquid. Okay. Now what is the length of the cylinder? Total length. Total length of cylinder is capital L. It is given in the question. Also it is given that length of the cylinder in the denser liquid is PL. It is given in the second last line of the question that the cylinder floats with its axis vertical and length PL in the denser liquid. Okay, so this length of the cylinder that is in the denser liquid is equal to PL. So what will be the length of the cylinder in the lighter liquid? It will be L minus PL. Okay, L minus PL, total length minus the length that is in the denser liquid. Okay. Now we'll start with the main part of the solution. We know that the weight of the cylindrical body must be equal to the upthrust provided by both the liquids. Okay, because it is present in both the liquids. Okay, so upthrust by both the liquids. So upthrust by the lighter liquid plus upthrust by the denser liquid. Okay, both the liquids are involved here. So this is the main part of the solution. Now what will be the weight? Weight of the cylinder will be equal to mg. G is the acceleration due to gravity and m is mass. And what is mass? Mass will be equal to density into volume. Okay. And what is volume? If we consider that the area of cross section of the cylinder is A, then volume will be area into length. Okay. So it can be written as D into area A into length L into G. This will be the weight of the cylindrical body. So let's put it here. Weight of the cylindrical body will be equal to DALG. Similarly, we'll put the same formula for the upthrust provided by the lighter liquid and denser liquid. Okay, upthrust means the weight of the liquid displaced. Okay, so what will be the weight of the lighter liquid displaced? Same formula. First we'll write the density, then area, then length, then acceleration due to gravity. So density of the lighter liquid we are talking about, right? Density of the lighter liquid is rho. Then area of cross section will be same. Okay, same as the cylinder A. Then what is the length of the cylinder that is present in the lighter liquid? It is L minus PL, right? So L minus PL. Then G. Got it till here? This is the upthrust. That means the weight of the lighter liquid that is displaced plus the upthrust by denser liquid. So here we'll put the values for denser liquid. So what is the density of the denser liquid? It is N rho. Then area of cross section will remain same. Now length of the cylinder that is present in the denser liquid is different. Okay, this is PL only. PL and then G. Got it? So till here it must be crystal clear to you. Okay. Now let's solve this. So DALG. This side let's take G common and A also common. Okay. Area and acceleration due to gravity can be taken common. So A and G common. So what is left this side? Rho, then L minus PL, and this side what is left? N rho, then PL. Okay. So A is on both sides and G is also on both sides. So these can be cancelled. So we'll further solve this. DL and this side we have, let's open the bracket. Okay, so rho L minus rho PL plus n rho PL. Now what can we do? We can take L common, right? So dl, and this side we are taking, we can take rho and L both common, right? So rho and L common, and this side we have 1 minus P plus NP. So L cancelled, and what is left this side? We have rho 1 minus P plus NP. Now if we rearrange this like this, we'll get, here I'm just rearranging this part. Okay, so NP minus P plus 1 and then rho. Okay, I have just changed the positions, everything else is same. Okay, now we can take P from this part common. Okay, so this side we have d small d that we have to find out, and this side we have, I'm taking P common, so what will be left? N minus 1, then this side we have plus 1 and then rho. Okay, so let's see if this is the solution. It can also be written as 1 plus n minus 1p. Okay, and then we can write rho outside the bracket because this is mentioned in the options. Okay, so just rearrangement is done here. So 1 plus n minus 1 rho and n minus 1p into rho. So let's see which option has this. In the first option we have 1 plus n minus 1p and then rho. This is the same thing that we have obtained. Let's match it again. 1 plus n minus 1p, then rho is outside the bracket. Okay, so 1 plus n minus 1 p and then rho. Okay, same. So option A will be the correct answer. Question number 28 is from the chapter Semiconductor Electronics, and the question is, consider the junction diode as ideal. The value of current flowing through AB is. Okay, so we have 2 points A and B. The potential at A is given as 4 volt and potential at B is given as minus 6 volt. Okay, resistance is given as 1 kilo ohm, that means 10 to the power 3 ohm. Now we have to find out the current. So that will be equal to delta V by R, because this is an ideal diode. Okay, so it will be simply delta V by R. Delta V means VA minus VB by R. Okay, VA is 4 volt, VB is minus 6 volt, and R is 10 to the power 3 ohm. So it is 4 plus 6, that is 10 by 10 to the power 3. So it is 1 by 10 to the power 2. That means 10 to the power minus 2, and the unit is ampere for current. So 10 to the power minus 2 ampere. That means option C will be the correct answer. Now question number 29 is from the chapter Friction, and the question is, a car is negotiating a curved road of radius r. The road is banked at an angle theta. The coefficient of friction between the tires of the car and the road is mu s. The maximum safe velocity on this road is. Okay, so we have a road that is inclined at an angle theta with the horizontal. A car is moving on this road, and this car is negotiating a curved path of radius r. Okay, we have to find the maximum safe velocity, that means the velocity with which the car should move so that it does not skid away. Okay, so I have represented the forces acting on this car. As you can see, one downward force is acting, and this is equal to mg. Then a force is perpendicular to the road, that is the normal force. Now this normal has two components, n cos theta just opposite to mg, and n sin theta that is perpendicular to n cos theta. Okay, now since there will be a frictional force also here, right? The car is moving in this direction, so a frictional force will be in the opposite direction, that means downward. Okay, so this is the frictional force Fr. Now this frictional force will also have two components, Fr cos theta and Fr sin theta. Okay, so the direction of Fr sin theta is same as that of mg. Okay, downward. Fr sin theta is here, whereas Fr cos theta is just perpendicular to Fr sin theta. Okay, here. Now there will be a pseudo force in this direction. Pseudo force, that is Fp that will be equal to mv square by r. mv square by r. Okay, so as you can see that these forces are balanced well. So this n cos theta that is on the top, this is balanced by the two downward forces, that is mg and fr sin theta, whereas this pseudo force mv square by r, it is balanced by two opposite forces, that is n sin theta and fr cos theta. Okay, so let's represent this balance in the form of equation. So first this n cos theta, the upward force n cos theta, is balanced by two downward forces, that is mg and fr sin theta. So we can write it that mg is equal to n cos theta minus fr sin theta. So let's take it as equation 1. This is the equation number 1. Similarly, the pseudo force, that is mv square by r, is balanced by two opposite forces n sin theta plus fr cos theta. So we can take it as equation number 2. Now we'll solve these equations to reach the conclusion. Okay, so let's divide equation 2 by equation 1. So on dividing equation 2 by equation 1, what do we get? On the left hand side, mv square by r divided by mg, and on the right hand side, n sin theta plus fr cos theta divided by n cos theta minus fr sin theta. So this m cancelled on the left hand side. Also we know that the frictional force is equal to the product of coefficient of friction, that is mu s as given in the question, and the normal. Okay, so frictional force is equal to mu s into n. So we can put this value in place of fr. Okay, so let's do that. On the left hand side, what is left? V square by rg is left, and on the right hand side we'll replace fr with mu s into n. Okay, so n sin theta plus mu s into n cos theta, and on the denominator side also n cos theta minus mu s into n sin theta, right? Now n can be taken common, so n sin theta plus mu s cos theta, and here n cos theta minus mu s into n, mu s sin theta. Okay, because n has been taken common, so n can be cancelled now. Now let's write it simply. V square by rg equals to sin theta plus mu s cos theta divided by cos theta minus mu s sin theta. Now if we divide the numerator as well as denominator by cos theta, okay, what do we get? Let's see. On dividing numerator as well as denominator of the right hand side only by cos theta. What do we get? We are not dividing on the left hand side, so left hand side will remain same, v square by rg, and on the right hand side, sin theta by cos theta will become tan theta. So tan theta plus, here only mu s will be left because cos theta will be cancelled. Then on the denominator side, cos theta cancelled, so 1 minus mu s sin theta by cos theta, that means mu s tan theta. Okay, so this will be left. We have to find the value of v. So from here we can say that v square will be equal to rg will go this side, tan theta plus mu s upon 1 minus mu s tan theta. So what will be the value of v? Just root of this, under root rg, or we can also write gr, tan theta plus mu s upon 1 minus mu s tan theta. So this will be the maximum safe velocity. Okay, under root gr then tan theta plus mu s upon 1 minus mu s tan theta. So let's see, under root gr. In the first option, g by r square is there, so this cannot be the correct answer. In the second option, gr square is there, this is also not correct. In the third option, under root gr is there, yes, this was in the answer. Mu s plus tan theta upon 1 minus mu s tan theta. This plus sign will not be there, okay? 1 minus mu s tan theta. So option C will be the correct answer. Question number 30 is from the chapter Moving Charges and Magnetism, and the question is, a long straight wire of radius A carries a steady current I. The current is uniformly distributed over its cross section. The ratio of the magnetic fields B and B dash at a radial distance A by 2 and 2A respectively from the axis of the wire is, okay. So according to the question, we have a long straight wire like this. Suppose this is the wire. The radius of this wire is equal to A. Right now there are 2 points at a distance A by 2 and 2A, and at these 2 points we have to find the magnetic fields, and then we have to find the ratio of the magnetic fields. Okay, so the first point is at a distance A by 2. That means if this is the center, then this A by 2 will be somewhere inside the wire. Okay, because the radius is equal to A, so A by 2 will be inside the wire. Okay, so this is the point A by 2. A by 2, and the second point is 2A at a distance 2A. That means it will be outside the wire, okay, somewhere here. So these are 2 points. Now at these 2 points we have to find out the magnetic field, but we know that the formula of magnetic field will vary inside and outside the wire. Okay, so let's talk about the first case, that means B inside. B inside, and the formula is mu naught I by 2 pi r square. Capital R is the radius, okay, according to the formula, into small r. Small r is the distance of the point, okay, at which we have to find the magnetic field. So here, according to the question, the radius is equal to A. So let's put A in place of capital R. Mu naught I by 2 pi A square into this distance is equal to A by 2, right? So A by 2. Now on solving this, we get mu naught I by 4 pi A. Okay, so this is the magnetic field inside the wire B. Now what about the outside? Outside magnetic field, the formula is mu naught I by 2 pi r. 2 pi small r. This small r is the distance. So here this small r is equal to 2A, right? So let's put this value, mu naught I by 2 pi into 2A. So what do we get? Mu naught I by 4 pi A. This is your B dash. Now we have to find the ratio, but it is quite clear that both are equal, right? We have got the same value. So B by B dash, the ratio will be what? Mu naught I by 4 pi A upon mu naught I by 4 pi A. So it is clearly this ratio is equal to 1. Okay, so option D will be the correct answer. 1 is the ratio of both the magnetic fields. Okay. Question number 31 is from the chapter Atoms, and the question is, given the value of Rydberg's constant is 10 to the power 7 per meter, the wave number of the last line of the Balmer series in hydrogen spectrum will be. Okay, so this is Balmer series, that means N1 is equal to 2. Then since last line is mentioned, so for last line N2 is equal to infinity. The value of Rydberg's constant R is given as 10 to the power 7 per meter. And let's write down the formula here. 1 by lambda equals to R 1 by N1 square minus 1 by N2 square. Okay, this is the formula. 1 by lambda is nothing but the wave number. Okay, that we have to find out. Wave number, it is the inverse of wavelength. Okay, so wave number is equal to Rydberg's constant, that is given as 10 to the power 7 per meter, and under bracket 1 by N1 square, so 1 by 2 square because N1 is 2, minus 1 by N2 square, that is 1 by infinity square, and we know that 1 by infinity is equal to 0. So this part is equal to 0. So what is left here? 10 to the power 7 per meter into 1 by 4. So 1 by 4 can be written as 0.25, right? 0.25 into 10 to the power 7 per meter. So this is the answer. This is the wave number that we have to find out. So 0.25 into 10 to the power 7 per meter. Option D will be the correct answer. Question number 32 is from the chapter Motion in a Straight Line, and the question is, if the velocity of a particle is v equals to at plus bt square, where a and b are constants, then the distance traveled by it between 1 second and 2 second is. Okay, so we know that velocity is equal to dx by dt, where x is the distance. Okay, so this value is given in the question. Dx by dt is equal to at plus bt square. Now we have to find out the distance, that is x, between 1 second and 2 second. So dx equals to at dt plus bt square dt. Now we have to integrate both sides. So integration of dx will be equal to a integration of t dt, because a is a constant. Okay, and it will be between 1 second and 2 seconds, plus this side also be outside because this is a constant, and then integration of t square dt between 1 second and 2 seconds. Now let's integrate. So this side we get a. Now we have to put t square by 2 and 1 and 2. Okay, between 1 and 2, plus b integration of t square will be t cube by 3. Okay, so t cube by 3, and we have to take the limit 1 and 2. Okay, that means how to do it? You know integration. First we'll put the value of t as 2, then minus the value of t as 1. Okay, so here we'll get 2 square minus 1 square upon 2, and this side 2 cube minus 1 cube upon 3. Okay, so this is how we integrate. Then here on solving this, 2 square, that means 4 minus 1 square, so 3. So here we'll get 3 by 2a plus 2 cube means 8 and 1 cube means 1. So 8 minus 1, 7. 7 by 3. 7 by 3b. So this will be the value of x. Okay, this is your answer. So let's match. In the last option we have 3 by 2a plus 7 by 3b. So option D will be the correct answer. Question number 33 is from the chapter Ray Optics and Optical Instruments, and the question is, the angle of incidence for a ray of light at a refracting surface of a prism is 45 degree. The angle of prism is 60 degree. If the ray suffers minimum deviation through the prism, then the angle of minimum deviation and refractive index of the material of the prism respectively are. Okay, so angle of incidence, that is I, is given as 45 degree, and angle of the prism A is given as 60 degree. We have to find two things here. First, the angle of minimum deviation, and second, the refractive index of the material of the prism. So this is a formula based question. You just have to remember the formula. First, we'll find the minimum deviation, that is denoted by delta minimum. So that is equal to simply 2i minus a. So let's put the values here. 2i, that means 2 into 45 degree, minus a is 60 degree. So what do we get here? 90 minus 60, that is 30 degree. So this is the angle of minimum deviation, 30 degree. Now second thing is refractive index, mu. Refractive index, that is mu, is equal to, what is the formula? Sine a plus delta minimum by 2 upon sine a by 2. So let's just put the values. Sine a is 60 degree, delta minimum is 30 degree, that we have just calculated, upon 2, and divided by sine a by 2, that means 60 by 2, right? 60 by 2. So on the numerator side we get sine 60 plus 90, 60 plus 30, 90, divided by 2, so sine 45 degree upon sine 60 by 2, that means 30 degree. Now let's put the value. Sine 45 degree is equal to 1 by root 2. And sine 30 degrees 1 by 2, so 2 will go up. On solving this we get root 2. So this is the refractive index. So the answers will be 30 degree and root 2 respectively. That means option C will be the correct answer. Now question number 34 is from the chapter Kinetic Theory, and the question is, the molecules of a given mass of a gas have RMS velocity of 200 meter per second at 27 degrees Celsius and 1 into 10 to the power 5 Newton per meter square pressure. Okay. So the RMS velocity is given, temperature is given, and pressure is given. Now, when the temperature and pressure of the gas are respectively 127 degrees Celsius and 0.05 into 10 to the power 5 Newton per meter square, then the RMS velocity of its molecules in meter per second is. Okay. So there are two situations. In the first situation, the RMS velocity is given. So V1 is given 200 meter per second. And temperature is given, that is T1 is equal to 27 degrees Celsius. So 27 degrees Celsius in Kelvin, it will be 300 Kelvin. Okay. So this is T1. Pressure is also given, but pressure is not required here. Why? Because we know the formula of RMS velocity. It is equal to under root 3 RT by M. Right? So pressure is not required here. We will consider the temperature only. Now in the second situation, the temperature, that is T2, is given as 127 degrees Celsius. And in Kelvin, it will be equal to 400. So 400 Kelvin is T2. And we have to find out the RMS velocity in this case. That means we have to find out the V2. Okay. So from this formula, we can say that VRMS is proportional to root T. Okay. Root T. So V1 by V2 will be equal to under root T1 by T2. So let's put the values here. V1 is 200 meter per second. V2 is unknown. We have to find out. Under root T1 is 300 Kelvin and T2 is 400 Kelvin. So here we get under root 3 by 4. Now we just have to find out the value of V2. So that will be equal to 200 into under root 4 by 3. And under root 4 will be equal to 2, right? So 2 into 200 will be 400 upon root 3. This will be your answer. So let's see which option has this answer. Option number C, 400 by root 3 is the correct answer. Now question number 35 is from the chapter Oscillations, and the question is, an air column closed at one end and open at the other resonates with a tuning fork when the smallest length of the column is 50 centimeter. The next larger length of the column resonating with the same tuning fork is. Okay. So again, two cases are there. In first case, there is the smallest length. That means we are talking about the fundamental frequency. So I have drawn the diagram of both the cases. Okay. A rough diagram. So in the first case, the smallest length is 50 centimeter. And we know that for first harmonic, the length will be equal to lambda by 4. So the value of lambda by 4 is given as 50 centimeter here. And in the second case, length will be equal to 3 lambda by 4. Okay. And we know that lambda by 4 is equal to 50. So it can be written as 3 into lambda by 4. And lambda by 4 is equal to 50. So 3 into 50, that means 150. And the unit is centimeter. So 150 centimeter will be the answer simply. So option D will be the correct answer. Question number 36 is from the chapter Magnetism and Matter, and the question is, the magnetic susceptibility is negative for. Options are paramagnetic and ferromagnetic materials, then diamagnetic material only, paramagnetic material only, and the last one is ferromagnetic material only. Okay. So what is magnetic susceptibility? It is denoted by the letter chi m. Okay. And it is the ratio of I and H, where I is the intensity of magnetization. Intensity of magnetization, and H is the magnetizing field strength. Okay. Magnetizing field. So we know that this magnetic susceptibility is negative only for diamagnetic material. Okay. For diamagnetic material it is negative, whereas for others it is positive. So for paramagnetic it is positive, but the value is small. Okay. But small. Whereas for ferromagnetic it is positive but large value. Okay. So here the question was asked about the negative, so it will be diamagnetic only. Option B will be the correct answer. Question number 37 is from the chapter Dual Nature of Radiation and Matter. And the question is, an electron of mass m and a photon have same energy E. The ratio of de Broglie wavelengths associated with them is. Okay. So what is the de Broglie wavelength of electron? Lambda E is equal to h by under root 2me, where E is the energy. Okay. Let's say this is equation number 1. And the de Broglie wavelength of photon will be equal to hc by E. This is equation number 2. Now we simply have to find the ratio. So de Broglie wavelength of electron upon the de Broglie wavelength of photon. This ratio will be equal to h by under root 2me into E by hc. H will be cancelled. So 1 by c, and then this root E will cancel 1 root E. So here root E will be left. So this will be equal to under root E by 2m. And this under root can be written as power of half. Okay. So 1 by c E by 2m to the power half. This will be the answer. So in option number B we have this, right? 1 by c E by 2m to the power half. So option B will be the correct answer. Question number 38 is from the chapter Work, Energy and Power, and the question is, a body of mass 1 kg begins to move under the action of a time dependent force vector F equals to 2t I cap plus 3t square j cap Newton when I cap and j cap are unit vectors along x and y axis. What power will be developed by the force at the time t? Okay, so power is equal to vector F dot vector v. Okay, this will be your instantaneous power. So for that we need to find the velocity, but velocity is not given. Okay, so first we'll find the acceleration. So acceleration is equal to force divided by mass. Okay, force is given as 2t I cap, 2t I cap plus 3t square j cap upon mass is given as 1 kg. So here we get 2t I cap plus 3t square j cap only. Okay, this is the acceleration. Now what will be the velocity? Velocity will be the integration of a dt. So let's integrate this. We have to integrate 2t dt I cap plus 3t square dt j cap. And on integrating this we'll get t square I cap plus t cube j cap. Okay. So this is your velocity. Now we'll put this in this formula. Okay. So power is equal to force vector F dot vector V. So what is vector F? It is 2t I cap plus 3t square j cap. And the velocity is t square I cap plus t cube j cap. So let's find the dot product. Here we'll get 2t into t square, that means 2t cube plus 3t square into t cube, that means 3t to the power 5. Okay, so this is the power. Let's match this answer. 2t cube plus 3t to the power 5, that means option A, and the unit is watt. Okay, option A is the correct answer. Question number 39 is from the chapter Current Electricity, and the question is, the charge flowing through a resistance R varies with time t as q equals to 80 minus bt square, where A and B are positive constants. The total heat produced in resistance is. Okay, so the charge q is given as 80 minus bt square, and we know that current will be equal to dq by dt. That is d 80 minus bt square by dt. And on differentiating this, we'll get the value of current, that is A minus 2 bt. Okay, this will be the value of current after differentiating the charge. Now, how long the heat will be produced? Till the current will keep flowing. Okay, once the current stops flowing, the heat will also stop being produced. Okay, now when current will stop flowing, that means when the current becomes 0, I equals to 0, then this value A minus 2 bt will be 0. okay, because this is the value of current. So from here we can say that 2bt is equal to A and time t will be equal to A by 2b. Okay. So till this time the current will keep flowing. After this time the current will stop flowing. Okay. That means the time limit is going to be 0 to A by 2b. Okay. Now we have to find out the heat. We know that heat is equal to I square R. We know the formula, right? So we have to integrate I square R dt in order to get the total heat produced in the resistance. Okay. What is the current I? It is A minus 2bt, A minus 2bt. So whole square and R dt. We can take R outside. So integration of A minus 2bt whole square. So we'll use the formula A minus B whole square equals to A square plus B square minus 2AB. Okay. So according to that, we'll get A square plus 4B square T square, right? Minus 4ABT and dt here. Okay. So we have to integrate them. We can write them separately first. Okay. So first integration of A square dt. Time limit is 0 to A by 2b. Okay. A by 2b. Here we have got time equals to A by 2b. Then integration of, this is t square. Okay. This is t square. 4b square t square. So integration of 4b square t square dt. Time limit is 0 to A by 2b. Then integration of 4abt dt. Again the time limit is 0 to A by 2b. Okay. I hope you know the basics of integration. Now here it is given that A and B are constants, so we can take them outside. So R A square integration of dt only. Time limit will be same. Okay. So I'm not mentioning time limit again and again. Then 4b square will be common here. So 4b square integration of t square dt minus 4ab will be constant. So 4ab integration of t dt. Okay. Time limit will be same 0 to A by 2b in all. Okay. Now here integration of dt will give us t. Okay. So R A square here will get t. Time limit 0 to A by 2b plus 4b square. Integration of t square is t cube by 3. So 1 by 3 can be taken outside and here t cube. Time limit 0 to A by 2b minus 4ab and integration of t is equal to t square by 2. So by 2 can be taken here and t square and time limit 0 to A by 2b. So now simply integrate it. What do we get here? Here we'll get R A square A by 2b. We'll keep the value, we'll write the value of t as A by 2b. Okay. Then here 4b square by 3, 4b square by 3 and here we'll get t cube, that means A by 2b cube. Okay. Minus 4ab by 2 and t square is there. So A by 2b square. Now you simply have to solve it and on solving it finally we'll get A cube R by 6b. Okay. So this will be the total heat produced. Okay. This is the total heat produced. A cube R upon 6b. So let's match A cube R upon 6b. Option number B is the correct answer. Question number 40 is from the chapter Semiconductor Electronics and the question is, an NPN transistor is connected in common emitter configuration in a given amplifier. A load resistance of 800 ohm is connected in the collector circuit and the voltage drop across it is 0.8 volt. If the current amplification factor is 0.96 and the input resistance of the circuit is 192 ohm, then the voltage gain and power gain of the amplifier will respectively be. Okay. So the load resistance or the output resistance is given as 800 ohm. Then the voltage drop is given as 0.8 volt. Next thing is current amplification factor 0.96. That means beta. Current amplification factor is represented by beta. So that is given as 0.96. And then the input resistance is given as 192 ohm. Now, first we have to find the voltage gain and then power gain. So we know that voltage gain is equal to current gain into resistance gain. Now current gain is nothing but beta and resistance gain will be equal to output resistance by input resistance, right? So let's put the values. Beta is 0.96, output resistance is 800 ohm and input resistance is 192. Okay. So on solving this, what do we get? We'll get 4. Okay. So this is your voltage gain. Now we come to the power gain. Okay. So power gain, we know that power is equal to voltage into current. So power gain will be equal to voltage gain into current gain. Now we know that voltage gain is equal to 4 and current gain is equal to 0.96. And on solving this, we'll get 3.84. So these two will be your answers. Voltage gain is 4 and power gain is 3.84. So 4 and 3.84, that means option B will be the correct answer. Question number 41 is from the chapter Thermal Properties of Matter, and the question is, a piece of ice falls from a height h so that it melts completely. Only 1/4 of the heat produced is absorbed by the ice and all energy of ice gets converted into heat during its fall. The value of h is, okay, so we have to find out the height h. Latent heat of ice is given and acceleration due to gravity is given. So at a certain height h, there is a piece of ice, okay. What will be the total energy stored in this piece of ice? It will be mgh, potential energy only. Now during its fall, this potential energy will get converted into kinetic energy and that will ultimately get converted into heat. Okay. Now it is given that 1/4 of the heat produced is absorbed. So how much heat is absorbed? Heat absorbed is 1/4 of the total heat, and the total heat is the conversion of this mgh only. That means mgh by 4. This amount of heat is absorbed by the ice. Now why this amount of heat is absorbed? Because in order to change the state, that means for the conversion of ice into water, the ice requires certain amount of heat. So this is that amount of heat. Okay. So we know that during the change of state, the amount of heat required Q is equal to M into L, where L is the latent heat. Now it is given that this amount of heat absorbed is 1/4 of mgh. Okay, so mgh by 4 is equal to M into L. So M is on both sides, so it can be cancelled. We have to find out the height h. Okay, so h will be equal to 4L upon G. Now we just have to put the values. So 4 into L is given as 3.4 into 10 to the power 5 and G is 10. Okay. So we'll have to solve it, and on solving this we'll get 136 into 10 to the power 3 meter. But the options are given in kilometer, so it will be 136 kilometer. Okay, this will be your answer. So option D will be the correct answer. Question number 42 is from the chapter Moving Charges and Magnetism, and the question is, a square loop ABCD carrying a current small I is placed near and coplanar with a long straight conductor X5 carrying a current capital I. The net force on the loop will be, okay. So this is the direction of the current in the loop. Just look at the arrow. Now the four sides of this loop will have different forces. Okay, so the net force will be the sum of these four forces. Okay, let's say this part will get F1 force, then CD will get F2, BC will get F3 and AD will get F4. Okay, So we know that whenever there are two straight parallel conductors, then the force per unit length between them is mu naught I1 I2 upon 2 pi r, where r is the distance between these two conductors and I1 and I2 are the currents in them respectively. Okay. So using this equation, we'll find out the forces on different parts of this loop. Okay. So force will be equal to what? Mu naught I1 I2 into L. Okay, L will go this side upon 2 pi r. Using this equation, we'll find the force. Now here you have to keep one thing in mind, that this F3 and F4 will become 0. Why? Because the angle between the straight conductor XY and these two sides will be 90 degree. Okay, so these two forces will be 0. That means only F1 and F2 will be considered. Okay, so let's find out the F1 and F2. F1 will be equal to mu naught, and I1 and I2 are capital I and small I, because the straight wire has the current capital I and the loop has current small I. Okay, into L. Okay, this is L, length of the loop, then upon 2 pi r. R is the distance between these two, so this is L by 2. Okay, the distance between XY and the side AB of the loop is L by 2. So L by 2. So 2 will go up here. L cancelled, 2 also cancelled. So what is left? Mu naught capital I small I upon pi. Okay, so this is F1. Similarly, we can find out the F2. So F2, that means the force between XY conductor and the side CD of the loop. Okay, so mu naught capital I small I into L upon 2 pi r. Now what is the r in this case? That means the distance between them is this capital L plus L by 2. That means 3L by 2. Okay, so 3L and by 2 will go up. So on solving this L will be cancelled, 2 will be cancelled. Here we'll get mu naught capital I small I upon 3 pi. Okay, this is the value of F2. Now the direction of F1 and F2 are opposite. So the net force F net will be equal to F1 minus F2. Okay, because their directions are opposite. So mu naught capital I small I upon pi minus mu naught capital I small I by 3 pi. Now let's solve it further. Mu naught capital I small I by pi can be taken common, and here we'll get 1 minus 1 by 3. So on solving this, what do we get finally? We'll get 2 by 3 mu naught capital I small I by pi. Okay, so this will be the net force. So let's match it. 2 by 3 mu naught capital I small I by pi. So I think option number D should be the correct answer, right? But option number B is also same. I think there is some printing mistake, but this will be your answer. Okay, whichever option has this one, that will be the correct answer. Question number 43 is from the chapter Waves, and the question is: a uniform rope of length L and mass m1 hangs vertically from a rigid support. A block of mass m2 is attached to the free end of the rope. A transverse pulse of wavelength lambda 1 is produced at the lower end of the rope. The wavelength of the pulse when it reaches the top of the rope is lambda 2. Then the ratio lambda 1 by lambda 2 is, actually the question was the ratio lambda 2 by lambda 1 is. Okay. So this is the correct question. There is printing mistake here. Now I have already drawn a diagram for that. Okay, it shows that there is a rigid support at the top, then a uniform rope is there whose length is capital L and mass is m1. Okay, then a block of mass m2, this is mass m2, is attached to the free end of the rope. Right now, a transverse pulse of wavelength lambda 1 is produced. Okay, like this. Okay, a wave will be produced from the lower end to the top. Okay, then the wavelength at the bottom, that means at this part, is lambda 1, whereas the wavelength at the top is lambda 2. Now we know that lambda wavelength will change, velocity will change, but the frequency will remain same. Okay, so we know that velocity is equal to under root T by mu, where T is the tension and mu is mass per unit length. So since this is a uniform rope, so this mass per unit length, that is mu, will remain same. So from here we can say that velocity is directly proportional to root t, because mu will remain constant. Now we also know that velocity is equal to frequency into lambda, okay, and frequency will also remain same, so this velocity is also proportional to lambda, okay. So these two things are important here. The velocity is directly proportional to root t and it is also directly proportional to the lambda, okay. We have to find the ratio of lambda 2 and lambda 1, okay. So lambda 2 by lambda 1 will be equal to v2 by v1, because velocity and lambda are directly proportional to each other. Now we have to find the answer in terms of mass. Now what is the value of T1 and T2? T1, that means at the lower end of the rope, here the tension is due to mass m2, okay. So T1 is equal to m2g. Whereas if we talk about the top part, here the tension is due to the rope, mass of the rope as well as mass of the block. So T2 is equal to m1 plus m2g, okay. So from here we can write that v2 by v1 is equal to under root T2 by T1, and T2 is equal to m1 plus m2g, whereas T1 is m2g, okay. So g will be cancelled. What is the ratio? Under root m1 plus m2 upon m2, okay. So option C will be the correct answer. Question number 44 is from the chapter Thermal Properties of Matter, and the question is, a black body is at a temperature of 5760 Kelvin. The energy of radiation emitted by the body at wavelength 250 nanometer is U1, at wavelength 500 nanometer is U2, and that at 1000 nanometer is U3. Wain's constant B is given as 2.88 into 10 to the power 6 nanometer Kelvin. So which of the following is correct? Okay, we have to find the most suitable option from here. Now what is given in the question? That when lambda 1 is 250 nanometer, then energy here is U1. Okay. Lambda 2 is 500 nanometer, then the energy is U2. And when lambda 3 is 1000 nanometer and energy is U3. Right? Now let's draw the graph showing the energy of emitted radiation versus the wavelength. Okay. So this side we have the wavelength lambda and this side we have the energy of emitted radiation. Emitted radiation. Now we know that the graph will look something like this. Right? This is the correct graph for this. So first of all, we'll find what will be the maximum wavelength. Okay, lambda maximum. So we'll use the Wain's displacement law for that. We know that Wain's displacement law, according to this law, Wain's displacement law, the maximum wavelength lambda max is equal to B upon T, where B is the Wain's constant and T is the temperature. So both these values are already mentioned in the question. The Wain's constant is given as 2.88 into 10 to the power 6 nanometer Kelvin. And temperature is given as 5760 Kelvin. So on solving this, we'll get 500 nanometer. That means the maximum wavelength is 500 nanometer. So this highest point will show the maximum wavelength. That means 500 nanometer will be somewhere here. So its corresponding energy will be U2. Okay, because 500 was given as lambda 2. Okay, lambda 2 was 500 nanometer. So this is the maximum wavelength and its energy is U2. So U2 is at the highest point. So from here we can say that U2 is maximum. Okay, then the lambda 1 is 250 nanometer. So it will come before 500. So it will come somewhere here. Okay, 250 nanometer and its corresponding energy will be somewhere here. Okay, U1. So U1 is less than U2. And if we talk about U3, so where is lambda 3? Lambda 3 is 1000 nanometers, so it will come after 500, so somewhere here. Okay, so its corresponding energy will be at this point U3. So U3 is also less than U2. Okay, Also we can say that we can see that u3 is more than u1, but the main point is u2 is maximum. Okay, u1 and u3 both are less than u2. Okay, so the correct relation between relation will be out of the given options. The first one can be correct because u2 is more than u1. Then the second one cannot be correct. u1 is not 0, u3 is also not 0, so the third one is also incorrect. And in the last one, u1 is more than u2. This is not correct because we have seen that u2 is maximum. So only option A is possible. Okay, option A will be the correct answer. And now the last question is from the chapter electromagnetic waves. And the question is, out of the following options, which one can be used to produce a propagating electromagnetic wave? So under what condition this electromagnetic wave will be produced? When there will be a sudden change in the electric field and magnetic field. Okay, so let's write it down here. It will be produced when there is a sudden change in the and magnetic field electric and magnetic field of a moving charge. That means the first condition is that the charge must be moving. Okay, so let's check the option. The first option is an accelerating charge. Yes, this can be correct because this statement also means that the charge must undergo acceleration or deceleration. Okay, must undergo acceleration or deceleration. So this can be the correct answer, but let's check other options as well. Second option is a charge moving at a constant velocity. This cannot be the correct answer because a constant velocity, due to the constant velocity, there will be no change in the electric and magnetic field. Okay, no change in electric and magnetic field. So electromagnetic wave will not be produced. Then the third one is a stationary charge. So we have already discussed that the charge must be in moving condition. Okay, not stationary. Then the last one is a chargeless particle. So this is clearly incorrect, that because the charge must be there, right? And it should be moving. So the only possible option is option number A, an accelerating charge. This will be your correct answer. Okay. So here we complete all the questions from NEET 2016 physics paper of phase 1. Okay. So that's it for today. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice the same questions from our website www.examsnet.com. And for more information, download our app from the link given in the description box. Thank you so much.